Hi class, this is Dr. O'Connor. Here we're going to go over a few concepts in Chapter 5. First, we'll talk a little bit about chemical reactions. We'll balance some right chemical reactions. Then we'll talk about precipitation reactions and finally neutralization reactions. I'll talk about oxidation reduction in another video. First, in a chemical reaction, we have the reactants and we have the products. A reactant is a substance that undergoes a change in the chemical reaction. And that's on the left side of the arrow. So reactants are on the left side of the arrow. And products are the substances or substance that is formed in a chemical reaction on the right side of the arrow. The numbers and the types of atoms must be the same on both sides of the reaction arrow. Why? Because of the law of conservation of mass. It states that mass is neither created nor destroyed in a chemical reaction. So in other words, you must have the same types and the same number of atoms on both sides of the chemical reaction. And think about it. Atoms don't just appear and they don't just disappear. Now, you'll notice labels like this next to the substances in a chemical reaction. So a solid is represented in parentheses with a lowercase s, a liquid, a lowercase l, gas, lowercase g, and aqueous with a lowercase aq. Aqueous means dissolved in water. So let's take a look at this equation here. Here we have sodium hydrogen carbonate or sodium bicarbonate, which is a solid. We have sodium carbonate that is produced, which is a solid. Liquid water is produced, and carbon dioxide gas. Notice the number in front of the sodium bicarbonate. This is called a coefficient. In fact, all of these substances have coefficients in front of them. This is a 2, and here is a 1. We just don't write the 1. We have a 1 here and a 1 here. Again, we don't write the 1. So the coefficient multiplies all the atoms in the formula. Let's take a look. So what we have here is 2 sodium atoms, 2 hydrogen atoms, 2 carbon atoms, and 2 times 3, 6 oxygen atoms. Here we just have 2 sodium atoms, 1 carbon, and 3 oxygen atoms. 2 hydrogen, 1 oxygen atom, 1 carbon, and 2 oxygen atoms. So the coefficients multiply all the atoms in the formula. It's the coefficients that are used to balance a chemical equation. So balancing chemical equations, step 1, write an unbalanced equation. Use the correct formulas for all reactants and products. So for example, diatomic molecules must be written like this. Step 2. We add coefficients to balance the number of atoms of each element. I usually leave oxygen until last. All right, I'll balance my metals, my polyatomic ion units. I'll balance all of the other atoms and save oxygen till last. I'll show you why in a moment. And then we have a big warning. You cannot change subscripts. The reason you can't change subscripts is because then you change the chemical formula. Step 3, check that the numbers and kinds of atoms on both sides of the equation are equal. Step 4, make sure the coefficients are reduced to their lowest whole number values. Let's go ahead and balance some equations. All right, here's our first one. So what I'm going to do is I'm going to start with the silver nitrate. So I notice on this side I have 1 silver atom. On this side, I have 1 silver atom. So we're balanced in silver. Now, one thing I notice, I could balance the rest of this by atom, or what I notice is I have a nitrate here, and I have 2 nitrate units here. So I can balance these as a unit, or I can balance them atom by atom. I'm going to go ahead and balance as a unit. So 1 nitrate here, we have 2 nitrates here. So I need to put a 2 in front of this so that I have 2 nitrates on both sides. Well, look what happened. Now I have 2 silver atoms on this side and only 1 on this side. So I'm going to put a 2 here. So now I'm balanced in silver and nitrate. Okay, let's take a look at magnesium. I have one magnesium atom on this side, and I have one magnesium on this side. We're balanced in magnesium. And then the chlorine, I have two chlorines on this side, so two chlorines, and I have two chlorines on this side, so we're balanced in chlorine. And then finally, let's look at let's see, we're balanced in magnesium, silver, nitrate, chlorine, and this is a balanced chemical equation. Okay, let's do this one here, this next one. And I'm going to balance the carbons and hydrogens first, and then I will balance my oxygens. So here I have two carbons. On this side I have one carbon, so I'm going to put a 2 here. So that gives me two carbons on both sides. On this side I have 6 hydrogens. On this side I have 2 hydrogens. So what I'm going to do is I'm going to put a 3 in front of the water. Okay, that gives me 6 hydrogens. I'm all balanced in hydrogens. Let's take a look at oxygen. On this side I have 2 oxygens. On this side I have 2 times 2, that's 4 oxygens plus 3 oxygens for a total of 7 oxygen atoms. Okay, so I need to balance my oxygen atoms. How do I do that? I have 2 on this side and I have 7 on this side. But these 2 oxygen atoms here, that's due to the molecular oxygen. So isn't it true that 7 oxygen atoms would be the same as 7 halves O2? Yes. So what I can do is I can put a 7 halves in front of this oxygen. Okay, and then what I need to do is get rid of this fraction. How do I do that? I multiply everything through by 2. So here I would have 2 of these, and 7 halves times 2 is 7. 2 times 2 is 4. 3 times 2 is 6. So I can put a 6 here. Whoops, let me get my pen. It's not very good. Okay, I can put a 6 here in front of the water. So now when I check, I have 4 carbons on both sides. I have 12 hydrogens on this side, 12 on this side. And I have 7 times 2, 14 oxygens. And here I have 4 times 2 is 8 plus 6, 14 oxygens. This is a balanced equation. Let's take a look here. Now in this one here, notice my hydroxide ion, I have it on this side, but on this side I have water. So I'm going to balance by atom. I have 1 calcium. Here I have 1 calcium. Here I have 2 oxygens. And on this side I have 1 oxygen. So I'm going to put a 2 in front of that. Here I have 2 hydrogens. 2 plus 1 is 3. Here I have 4 hydrogens. So I'm just going to put a 2 in front of this. And then I have 2 chlorines on this side and 2 chlorines on this side. This is a balanced chemical equation. Now let's go ahead and write a balanced equation. We're told that we have solid magnesium and it's burned in oxygen to produce solid magnesium oxide. Write a balanced equation. So solid magnesium, I would write that in its elemental state. It's burned in oxygen. We know that oxygen is a diatomic and it's a gas. And it produces magnesium oxide, and they tell us it's a solid. So is this balanced? Well, I have 1 magnesium on this side, 1 on this side, yes. 2 oxygens on this side and only 1 on this side. I'll put a 2 here. Now that gives me 2 magnesiums. I'll put a 2 here. This is a balanced equation. Let's take a look at this one. Hydrofluoric acid is used to etch glass, which is silicon dioxide. The products are silicon tetrafluoride and water. Write a balanced chemical equation. Hydrofluoric acid is written like so, and silicon dioxide like so. And the products are silicon tetrafluoride plus water. So let's see now if this is balanced. Let's first take a look at the fluorine here. There's 4 on this side. I'm going to put a 4 in front of this. And that gives me 4 hydrogens. I only have 2 here, so I'll put a 2 in front of that. And then we have 1 silicon on both sides and 2 oxygens. That is a balanced equation. Practice balancing equations. You'll see those on the exam. All right, let's talk about some different types of chemical reactions. We're going to talk about 3 types here. Precipitation reactions. We're going to talk about neutralization reactions, and in the other video, what we call redox reactions. So let's talk first about precipitation reactions. A precipitate. This is an insoluble solid that forms in solution during a chemical reaction. In other words, it's a solid. Before we look at one of these reactions, let's talk about the term solubility. This is the amount of compound that will dissolve in a given amount of solvent at a given temperature. So, for example, sodium chloride, there's a limit to how much sodium chloride we can dissolve in, let's say, 100 milliliters of water at 25 degrees Celsius. Let's take a look at this reaction here. This is a precipitation reaction. How do we know that? Because here we mix aqueous silver nitrate with aqueous potassium chloride. And look, we have solid silver chloride produced and also aqueous potassium nitrate. So this is an example of a precipitation reaction. So we mix together these 2 solutions and we end up with these 2 products. One of them is a solid. So how do we know that that solid silver chloride forms? Well, we use what we call the Solubility Guidelines. So Solubility, guidelines, or solubility rules, if you will. Okay, here are the rules that we follow. Rule number 1, a compound is probably soluble if it contains one of the following cations. A cation from group 1A or the ammonium ion. So any compound that contains ammonium ion or group 1A cation is soluble. Again, we're talking ionic compounds here, okay? Rule number 2, a compound is probably soluble if it contains one of the following anions. A halide, chloride, bromide, iodide. Some exceptions are halide compounds that contain silver, mercury, and lead. Okay? All nitrates, or all compounds that contain nitrates, are soluble. All compounds that contain perchlorate ion are soluble. All compounds that contain acetate ion are soluble. All sulfates are soluble except for ones that contain barium, mercury, and lead. You can consider compounds that contain other ions insoluble. So let's take a look at some examples here. Are the following soluble or insoluble in water? Ammonium chloride. This is soluble. All ammonium compounds are soluble. All compounds that contain chloride ion are soluble, except for these 3 ions here. Sodium sulfide. Yes, that's soluble. All compounds that contain sodium are soluble. Cadmium carbonate. Well, I don't see anything about cadmium or carbonate here, so this is insoluble. Nickel 2 chloride. Chlorides are soluble. Nickel is not one of those exceptions, so this is soluble. Lead 2 sulfate. All sulfates are soluble, except if they contain lead. So this is insoluble. And then we have magnesium hydroxide. I don't see hydroxide ions on here. Magnesium is not a group 1 metal, therefore this is insoluble. So practice these. So you might be given an equation like this. You've got two ionic substances that are dissolved. They say aqueous. So what we want to do is determine if a precipitation reaction occurs. So here's how you do this. We're going to replace each of the cations. So we're going to replace the nickel with the ammonium ion. So here we would have ammonium chloride. And then we'll replace the ammonium with the nickel. So this would give us nickel 2 sulfide. What we do next is we check our solubility rules to see if these products are soluble. Ammonium chloride is soluble. We know that. We'll put aqueous here. Nickel sulfide, is that soluble? Well, according to the solubility rules, I don't see anything about sulfides. In fact, sulfides are all insoluble unless they're combined with ammonium or one of the group 1A metals. So this would be insoluble. That would be a solid. Let me show you what's happening in solution. So we have the nickel chloride and the ammonium sulfide. So here is the nickel chloride. These are aqueous. So what we have is, remember, ionic compounds will dissociate. So we have chloride ions and nickel ions. And then we have the, what is it, the ammonium sulfide. Again, ammonium sulfide is soluble. So what we have is ammonium ions and sulfide ions. Okay? Now, when we mix these together, here's what we get. We get sulfide ions, we get nickel ions, we have ammonium ions, and we have chloride ions. Well, it turns out that the nickel sulfide is insoluble. So what happens is that nickel and the sulfide ions will come together and form solid nickel sulfide. And what we end up with in solution are ammonium ions and chloride ions. They don't have any attraction for one another, so they're just in solution as ions, whereas the nickel and sulfide ions are very attracted to one another and form a solid. So that's what's happening in solution. I can go to this diagram that I just drew, and I can write what we call an ionic equation for this reaction. So here's what we have. On the left side, we have nickel ions. That's aqueous, by the way. And we have chloride ions. Okay. And by the way, we have to make sure this equation is balanced, okay? It is now balanced. And then we have the ammonium sulfide. So we also have ammonium ions. We'd have 2 of those, plus sulfide ions. Okay, and these are dissolved. Now, on this side, we have ammonium chloride, which of course is dissociated into ammonium and chloride ions. We have 2 of those. And then what we have is, as I showed you in this drawing, our nickel sulfide is a solid. So what we have here is this ionic equation. And look what happens. Notice my 2 chloride ions and my 2 ammonium ions on both sides cancel out. And what I can do is write my net ionic equation. What do I have left? I have nickel 2 ion. 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 2 plus sulfide ion to produce solid nickel sulfide. This is my net ionic equation. The net ionic equation is nice because it shows you which ions are involved in the reaction. The ammonium ions and the chloride ions in this case, the ones that canceled out, these are called the spectator ions. They're there, they just don't take part in the chemical reaction. Remember, ionic compounds are salts. And in order to obtain ions, I have to dissolve a salt. So basically, I could have gotten the same reaction if I would have dissolved, let's say, nickel bromide and sodium sulfide. I still would have gotten the same net ionic equation. By the way, this overall equation, this is called the molecular equation. So I would expect you to be able to write a molecular, an ionic, and a net ionic equation. So let's take a look at this one. Here we have sodium chloride and potassium nitrate. So let's go ahead and write the equation or the products for this. Again, I'm going to replace the sodium here with the potassium. So I'm going to end up with potassium chloride. And I'm going to replace the potassium with the sodium. And I'm going to end up with sodium nitrate. We go to our solubility rules. Is potassium chloride soluble? Yes. Is sodium nitrate soluble? Yes. Let's write the ionic equation for this. And what I'm going to have is, we've got sodium ions plus chloride ions, and the equation, the molecular equation is balanced, plus potassium ions plus nitrate ions. And then on this side, I've got potassium chloride, which is, again, soluble, chloride ions, plus sodium nitrate, which is soluble, plus nitrate ions. Look what happens here. These all cancel out. That means there is no reaction. Everything cancels. No solid is formed. So that's an example where we have no precipitation reaction. Okay? I'm going to do another one for you. And I think I'm going to do it up here. So let's start here. So what happens when we mix lead 2 nitrate with potassium iodide? We know that lead 2 nitrate, all nitrates are soluble. Potassium iodide is soluble. So let's see what happens. We'll go ahead and replace the lead with the potassium. So we end up with potassium nitrate. And then we'll replace the potassium with the lead. So we have, you just have to make sure you write your formulas correctly here. Lead 2 iodide. From the solubility rules, we know that potassium nitrate is soluble. And we know that lead 2 iodide is insoluble. So a precipitation reaction does occur here. Let's go ahead and write our ionic equation. So we have lead ion. And we have, what we need to do here is balance the equation first, sorry. Here I have 2 and a 2. So this is now balanced. So we have lead 2 ions. And then we have 2 nitrate ions, because again, the lead 2 nitrate is soluble. And potassium iodide, so we have 2 potassium ions plus 2 iodide ions. Let's go to this side. Potassium nitrate is soluble, so we can write it like this. But this is a solid, so we have to keep it like so. Okay, so that's our ionic equation. So we have our molecular equation, our ionic equation. Now let's write our net ionic. Notice nitrates cancel, potassium ions cancel. So we're left with plus 2 iodide ions to give us lead 2 iodide. The actual reaction is between the lead ions and the iodide ions, and our spectator ions in this case, our spectator ions are potassium and nitrate ions. So practice these, and if you have any questions, please let me know. Okay, that's it for precipitation reactions. The next type of reaction that we're going to talk about, I'm going to go ahead and erase this out of here so it looks a little bit neater. All right, there we go. We're going to talk about neutralization reactions. And neutralization reactions are very important reactions, just like precipitation reactions are. And they are the result of the reaction between an acid and a base, which produces water and a salt. Remember, all ionic compounds are salts. Okay? So here we have an acid and sodium hydroxide, which is a base. And the reaction here produces water and sodium chloride. So just like before, what I do here is I replace the hydrogen with the sodium. Okay, so I end up with aqueous sodium chloride. And here I replace the sodium with this hydrogen, and that gives me water. So this is a neutralization reaction. Acids tend to give up their hydrogen ion, and bases tend to accept the hydrogen ion. So we end up again with water and a salt. Here's another reaction. Here we have hydrochloric acid, and it turns out that carbonate ion will act as a base. So again, what I'm going to do is I'll replace the hydrogen here with the potassium, and I end up with my salt, my potassium chloride. And again, that's dissociated. It's aqueous. And then replace the potassium with the hydrogen. And here I get an acid called carbonic acid. It turns out the carbonic acid is very unstable. So it tends to decompose to water and carbon dioxide. I can rewrite the equation like so. If I have a carbonate, what I do is start off with my acid here plus the potassium carbonate. And I know that potassium chloride is going to form, and I know this carbonic acid is going to form and then decompose to water plus carbon dioxide gas. Practice writing these neutralization reactions, recognize them. So now you know two different types of reactions: precipitation reaction and neutralization. So everybody have a good day. Let me know if you have any questions. I'll be more than happy to answer them. I'll do redox in the next video.